Assalamualaikum warahmatullahi wabarakatuh. Today I want to present about my PSM2. My PSM2 title is Blind Spot Detection System on Vehicles. Firstly, I want to introduce myself. My name is Firhan Rizadi bin Abdul Razak. My metric number is CE170168 and my supervisor is Encik Aizan bin Ubin. For the project background, as we know nowadays, there are many vehicles that using roads. The increasing number of vehicles will cause more traffic accidents. The statistics by Malaysian Road Safety Department show that fatal accidents from 2009 until 2019 increased exponentially. Safety driving is important for each individual. One of the reasons accident happening is because four-wheel vehicles driver not alert about incoming motorcyclists from behind. Each vehicle have side mirror, but side mirror has its limit. Side mirror cannot see the image of motorcyclists because there are blind spot region from side mirror. For the problem statement, side mirror is must use in every vehicles. The function of the side mirror is to see the reflection of object at behind, because human doesn't have eyes at the back of their head. So, if each time human want to check behind object, they must turn their head. This will make the driver lose focus to the situation at their front. The side mirror have a blind spot region that it cannot show the image. So, this project is to overcome the weakness of the side mirror. This project can show the distance data and give alert to the driver. With this innovation, the driver knows when is the right time to change between lanes. Objectives of this project. First is to design a radar system that could monitor the movement of other vehicles. Second is to provide distance data to the drivers while driving. And lastly is to give alert to the driver when they have vehicles approaching from behind. For the scope of this project, this system uses ultrasonic sensor HCSR04 as the radar system for detecting the other vehicles. Secondly, the Arduino Uno is used as a microcontroller that processes the data for showing to the drivers. LCD 16:2 display is used to inform driver about distance data by showing the data through it. And lastly is LED and buzzer used as an indicator to give alert to the driver. It will activate if another vehicle is in dangerous position. For the methodology, firstly, I program the microcontroller and the ultrasonic sensor, and then I do a test to detect the range of distance of an obstacle. Next is I develop the detection system, and I make a connection between the microcontrollers and the LCD display, and I test the product, and it show the distance data successfully. For the result and analysis, my first analysis is I want to analyze the error of the ultrasonic sensor. I do this experiment is by putting a flat object is put in front of the sensor as an obstacle. Then I take the value of the distance from the serial monitor in the Arduino software. The actual distance of the object is measured using a ruler, and I calculate the percentage error that occur in the project. This is the setup of my analysis. This is the obstacle, and I attach the ultrasonic sensor at the wall. As we can see this, the percentage error of the ultrasonic sensor is very small. So this sensor is suitable for this project to use. My second analysis is I want to analyze the region covered by the ultrasonic sensor. For this experiment, I attach the ultrasonic sensor on a wall. The distance of either side of wall is more than 5 meters. So I do this experiment at a large area that the distance wall from another wall is 5 meters. I put an obstacle 1 meter apart from the ultrasonic sensor. So I move the obstacle from one side to another side of the ultrasonic sensor until it cannot detect. I mark the point from side to side by a tape, and I measure the angle by using a protractor. This is the setup of the experiment. Firstly, I attach the ultrasonic sensor to a wall, and as you can see, it shows 5 meters. That means the other wall is 5 meters apart. Then I put an obstacle 1 meter from the sensor and this can measure by using this ruler. Then I mark by using a tape on the floor. Then I move to the other side until it gets to maximum point, until it cannot show the actual distance. And I also mark by using a tape. Then I measure using a protractor, and the angle that I get is 60 degrees. That means the ultrasonic sensor can measure a region about 60 degrees. For the next analysis, I want to analyze the response system towards the incoming vehicles. For this experiment, a motorcycle is used as an object to be detected. The ultrasonic sensor is mounted on a stick and the height is about 50 cm above the ground. The distance to activate the buzzer and LED is 100 cm or 1 meter apart. As you can see, this ultrasonic sensor is mounted on a stick that 50 cm above the ground. I move towards the sensor, and if the motorcycle is 1 meter apart from the sensor, it will light up the LED and will ring the buzzer. For the last analysis, I want to analyze about the speed of the obstacle. I use the same method from the previous experiment. The motorcycle moves towards the sensor at a constant speed. So the data taken is from the serial monitor of Arduino IDE software. As you can see here, the reading of the distance from the first reading until the last reading, the distance is decreasing. That means the motorcycle is moving towards the sensor. As we can see here, the data of the speed is inaccurate. This is because the ultrasonic sensor cannot give the precise data from a fast object. For the conclusion, this project is the improvement idea to minimize accidents that happen from the blind spot. The convex blind spot mirror can allow the driver to look on the object on the side of the car, but the image is distorted and making evaluating distance is difficult for the driver. This project will improve the traditional way to detect blind spot region. The system also can provide information about objects that are outside of the eyesight range of the driver. The benefits of this project is driver can change their lane safely, especially on the busy road. And hopefully this project can implement at the low-end cars and vehicles that doesn't have its own blind spot detection system. For the recommendation, using Arduino Uno can attach with two ultrasonic sensors at the same time. That means it can put the ultrasonic sensor at the right and at the left of the vehicles. Then maybe by using Arduino Mega also can improve the calculation of the data and the accuracy of the data calculate. For the sensor used in this project is ultrasonic sensor HCSR04. The HCSR04 detection region is small and shorter range. It cannot detect objects that more than 4 to 5 meters. This causes the reading of the data inaccurate. Maybe by using high specification ultrasonic sensor can overcome some problems that happen in this project. That's all from me for this project. Thank you.